Hi, I am Sheikh Mahbub Basha. Welcome to my channel. Happy Learning. Hi students, welcome. Here we have given one note point. If the speed of an object increases, the direction of velocity and acceleration are one and the same. If the speed of the object increases, take an example of a body falling onto the ground. This is ground. A body is falling onto the ground. As it approaches towards the earth, its speed increases, velocity increases. Here, its velocity is in the downward direction, its acceleration is also in the downward direction. Right? So, velocity is downward direction, acceleration is also in the downward direction. If the speed of an object increases, so here for the falling body, speed is increasing gradually. The direction of velocity, so here the direction of velocity is downwards, starting point to end point. Direction of velocity and acceleration are one and the same. Here acceleration is also vertically downwards and velocity is also vertically downwards. Next point. If the speed of an object decreases, the direction of velocity and acceleration are in opposite directions. In such a case, at a certain instant, the speed becomes 0. So this is the case of a vertically projected body. Suppose a body is projected vertically upwards. Initially it has some speed, slowly its speed becomes reduces and finally becomes 0. Here final velocity becomes 0. Initially you have given some initial speed v. So here direction of velocity is upwards. Direction of velocity is upwards, whereas the direction of acceleration is downwards. So velocity direction is upward, acceleration direction is downward, and at this point at a maximum height, its velocity becomes 0. After reaching certain height, its velocity becomes 0. If there exists an acceleration of a body at a point where its speed becomes 0 for an instant, then the body returns in the direction of acceleration and moves continuously. So this is the case of body projected vertically upwards. This body is projected vertically upwards. Initially you have given some speed u. Finally here its velocity becomes 0. Then again it falls onto the earth. So here, while moving upwards or downwards, its acceleration is always downwards. Acceleration is always downwards, whereas speed, velocity, while moving upward is upward, and here it is downwards. Okay. If there exists acceleration of a body at a point where its speed becomes 0, here speed has become 0. But still acceleration exists. How this acceleration? It is due to attraction of earth. If there exists acceleration of a body at a point where its speed becomes 0, means this point for an instant, then the body returns in the direction of acceleration. So this body returns in the direction of acceleration. This is the direction of acceleration. Body returns in the direction of acceleration and moves continuously. So this body is first thrown vertically upwards. So this is the direction of velocity. It is moving upwards because of earth attraction. Its speed reduces and finally becomes 0. Still there exists attraction of earth. So at this point for a moment its velocity becomes 0, but still there exists acceleration. Therefore its direction changes and the body starts moving in the direction of acceleration. Okay. Next, we have got a lab activity. Aim is to find the acceleration and velocity of an object moving on an inclined track to draw the graph between distance and time. Materials required are glass marbles, book, digital clock, plastic tubes and steel plates. Arrange some stack of books, put a plastic track as an inclined plane, release a marble and note down the time taken to reach the ground using a digital clock. Okay. Values are substituted in this table versus time T1, T2, T3. So 3 times trial 1, trial 2, trial 3 are taken and average of these 3. T is equal to T1 plus T2 plus T3 by 3 and 2s by T square is the formula for acceleration. So this is inclined plane. A body is released from this point and it has rolled to this point. Initial at time t is equal to 0 it is dropped. Its speed is 0 and after t seconds it has reached the bottom. So here its speed is unknown. Let the displacement is s and acceleration is a. So using the formula s is equal to ut plus half at square. Here u initial velocity is 0, 0 into t plus half at square. So s is equal to half at square. This term becomes 0. Then 2s by t square is equal to a. 2 is taken to this side, t square is taken to this side. So you can find the formula, find the acceleration using the formula 2s by t square. So we are going to use this expression a is equal to s by t square to find the acceleration of the body rolling down the inclined plane. Okay. Let us start the experiment. Select an experimental bench using a meter scale and a marker. Let us mark at 100 centimeters from one edge of the table. Then from 100 centimeter mark, let us mark another mark at 125 centimeters. 100 plus 25 total becomes 125 centimeters. Then at 50 centimeters, so 100 plus 50 becomes 150 centimeters. So we have marked 3 marks from one edge of the table. This is the stopwatch. This button is used to start and stop the clock, and this button is to bring it to 0. This is the cylinder used as rolling body in this activity. This is the table we are using for this experiment. It has the columns serial number, slope, displacement s measured in centimeters, time of travel of the cylinder, trial 1 t1 seconds, trial 2 t2 seconds, mean t is given by t1 plus t2 by 2 and is in seconds, t square units will be second square, acceleration a is equal to 2s by t square. Now we are selecting displacements 100 centimeter, 125 centimeter and 150 centimeter for slope 1, and similarly 100 centimeter, 125 centimeters and 150 centimeters for slope 2. Then for slope 3 we are selecting 100 centimeters, 125 centimeter and 150 centimeters. Now put some mass under the bench to create a slope. Now the cylinder is dropped from 100 centimeter mark. Simultaneously the stopwatch is started. Stop. The time taken for travel is noted and is tabulated. Under trial 1 it is 4.5 seconds. Then make 0 and then release the cylinder from 100 centimeters and By the time the cylinder reaches the edge, stop the watch and note down the time. This time it is recorded as 4.5 seconds. Now the experiment is repeated for 125 centimeters. Release the cylinder from 125 centimeters and note down the time taken. The value is 5 seconds and is noted in the table under trial 1. Now for the same 125, trial 2. So the time taken is noted using this stopwatch. This time it is noted as 5 seconds and is recorded in the table under trial 2. Now let us repeat the experiment for 150 centimeters. Stop. So the time for 150 centimeter distance is noted as 6 seconds under trial 1. Let us repeat the same for trial 2. So the cylinder is rolling. Stop. The time is recorded in the table under trial 2. It is 6 seconds. Now some more mass under the bench to increase the slope. Now this is experiment for slope 2. The experiment is repeated for 100 centimeter in slope 2. This is trial 1. The value is noted in the table against slope 2 100 centimeter. Trial 1 is 3.5 seconds. Then the experiment is repeated for trial 2 for the same 100 centimeter and slope 2. Time taken is again 3.5 seconds. For more accuracy, you can use mobile phone stopwatch that will give digital values. Here we are using laboratory stopwatch. So for 125 centimeters under trial 1, the time taken is 4 seconds. Then let us repeat this experiment for 125 centimeters. The time is again 4 seconds. Note it under trial 2. Then the experiment is conducted for 150 centimeters. Stop. Stop. The time taken is 5 seconds. It is noted under 150 centimeter under trial 1. Start. Stop. This time the time is 5 seconds. It is noted under trial 2. Slope 2 150 centimeter, trial 2. Now add some extra mass under the bench to increase the slope. Now this is a slope 3 condition. Now let us repeat the experiment from 100 centimeters for slope 3 100 centimeters. The time is noted. It is recorded in the table slope 3 100 centimeters, trial 1 3 seconds. Let us repeat for trial 2. Start. Stop. The time is again 3 seconds. Now let us conduct the experiment for 125 centimeter. Now the time is for trial 1 3.5 seconds, and for the same 125 repeat the experiment. Trial 2. This time taken is noted as 3.5 seconds. Write down in the table against 125 centimeters under trial 2. Now make 0. Start. Stop. The time is 4 seconds. Note it under slope 3 150 centimeter, trial 1 is 4 seconds. Start. Stop. So for 150 centimeters, the trial 2 value is 4 seconds. Write down in the table. The mean values of time are calculated using T1 and T2 using formula T equal to T1 plus T2 by 2.
that will be in seconds. Fill the table, then calculate t square for each row, and then using a equal to 2s by t square, the values are calculated and are tabulated. In slope 1, there are 3 accelerations. In slope 2, 3 accelerations. Slope 3, 3 accelerations. For slope 1, average of 3 values is calculated, and similarly for slope 2, find the average of all the 3 acceleration values, and similarly in third case for slope 3, find the average acceleration from the 3 accelerations we got. So we can notice that as the slope is increased, acceleration is increased.
This is x-axis. Time is taken on x-axis. So time t in seconds. Let it be 1, 2, 3, 4, 5, 6 seconds. And this is y-axis. Displacement s in meters is taken on y-axis. So 25, 50, 75, 100, 125. So let us draw the graph. On x-axis, time t in seconds is taken. So these are the times: 1 second, 2 second, 3 second, 4 second, 5 second, 6 second, and so on. This is x-axis, and this is origin. On y-axis, displacement in meters is taken. Let it be 25, 50, 75, 100, and so on. Now let us note down the points. So here it is for 100 centimeter. So when time is 4.5, displacement is 100. When time is 4.5, this is 4 and 5, between 4.5, and the displacement is, we want 100. This is 100. For 100, 4.5, this is the point. This is the point. This is 4.5 comma 100. Similarly, we have 5 comma 125. For the time 5, displacement is 125. So let me note down for 5, 125. So this is the point, 5 comma 125. And then for time 6, displacement is 150. So for time 6, displacement is 150. So this is the point, 6 comma 150. So if you join this, we got something like this. Similarly, let us join black color, red color कितना है? This is for slope 1. This is for slope 1. For slope 2, for 3.5, it is 100 centimeters. For 3.5, 100 centimeters. This is the point. And for 4, it is 125. So for 4, it is 125. This is the point. And for 5, 150 centimeters. So for 5, 150 centimeters. So this is the point. So we got this graph for slope 2. For slope 2. Then similarly for slope 3, for time 3, displacement is 100. So at time 3, displacement is 100. This is the point. And for 3.5, it is 125. So for 3.5, it is 125. And for 4, it is 150. So for 4, it is 150. So this is the graph. So joining this is for slope 3. So we got three curves, slope 1, slope 2, slope 3. Actually, these graphs will be something like this way. So these will be the actual graphs. So under experimental errors, we got these. So as the slope increases, initially slope 1, we have taken very small mass under the bench. Next we have increased the mass. Next we have further increased the mass. So here, this is for slope 1, slope 2, slope 3. More the slope, this graph becoming steeper. Okay, right. Now, so from this table, we can notice that for the smaller the slope, smaller the acceleration. When slope is increased, acceleration has increased. When further increasing of slope, acceleration has increased. So when slope is increased, the acceleration has increased. The ST graph is a curve, not a straight line. More the slope, steeper the curve. Every curve starting from origin.